All right, here's the end of that last problem. Negative 2 is from this factor, and then here we get positive 1/2. Okay, so there we go. All right, so just review the process again. Start by dividing the function using the 0 they give you. Okay, and then once you get to that point, you just rewrite the function. Instead of this x cubed function, we wrote it as this linear x minus 3 times this quadratic. And then from there, all algebra 2 review. Okay. All right, pause and you try it for 13. Okay, here's your feedback on this one. X plus 1 is our factor if this is a solution. So we're dividing this function right here by x plus 1. And here's the work. And we should get a remainder of 0 because we know that x plus 1 is a factor. Okay. All right, so now we should rewrite the function. We're going to write it as x plus 1, our divisor, times this result, and then continue to solve it from there. This is the new part. All of this should be reviewed if you've been staying up on your skills. Okay, so factors of negative 30, add up to negative 1 are going to be 5 and negative 6, and it factors pretty nicely. Okay, so here's the zeros. Pause and fix what you need, or rewatch if you need to. Okay, let's move on to 14 and 15 now. It's going to piggyback a lot off what we just did. Okay, it says find the remaining factors of f of x. Use the results to write the complete factorization of f of x. Basically, complete factorization just means down here, break it down as far as you can. Okay, and then go ahead and list all the zeros of the function. All right, so when they give us multiple factors, you actually have the option to do repeated division if necessary. Okay, so when given multiple factors, okay, so by multiple, what do I mean by that? Up here, we only really could create one factor. It's only give us 1, 0. So I don't have multiple factors, I only had one. Here, when given multiple factors, we can use what they call in the book as repeated division. Okay, so I'll show you what that's going to look like. All right, so to get this one going, we're going to start off the same way with the steps at the top. Divide the function. Step 1. It actually doesn't matter which one you want to use. I could use k value of 4 or k value of negative 2. I'm just going to start with the one that they gave us first, okay? So if I'm going to divide this by x plus 2, then negative 2 is my 0. Okay, 1, 2, negative 16, negative 32. Add, multiply. Add, multiply. Keep going. Okay, so I got remainder, constant term, linear term, quadratic, right? So it's like this. 1x squared, nothing here, minus 16 is the result. So I can break down this function now. 0 equals what I divided by, x plus 2 times the results, x squared minus 16. Okay, just to make sure you understand, remember this replaces this. If I were to multiply this back out and FOIL it, this is what I'd get. I promise you. Okay. All right, so now since we have another factor, we have the option to use repeated division. You actually have 2 ways we could go about this. Let me go through the repeated division though first. All right, so I can continue to break this down with x minus 4, the other factor. Okay, so just do it the way we've done 3 other times so far. So I'm going to take this function and divide it by x minus 4. So 4 is here. I've got 1x squared, 0x, and minus 16. Add, multiply, add, multiply, add. So the result is 1x plus 4, right? Remainder 0. Okay, so now I can rewrite x squared minus 16. So I have x plus 2, and then this is going to be rewritten as my divisor times the answer. Okay? So find the remaining factors. I did. It's really just one. They already gave us 2 of these. To write the complete factorization, check, and list all the zeros. So my zeros are -2 and then plus or minus 4. All right, now if you noticed, I said the word you can. We didn't have to use repeated division here. You can. I mean, we could have factored this using difference of 2 squares and gotten here right away and got the solutions quicker. I get it, and you're more than welcome to do that. All right, but for a problem like 15, we might really want to rely on this a little more heavily. So here we go, last problem. Just pick one. Let's go ahead and just start with the first one again. 2 is what I'm going to divide this function by. I'm sorry, divided by x minus 2, so 2 is our k value, or 0. So 2, 7. Okay, if you want to pause and try to get ahead of me and try any parts of this, go ahead. But since it's a little bit different 14, I need to help you with this one right now. Add the 2, multiply. Here's the math for it. Okay, so right now, how can I rewrite this function? Step 2. I divided by x minus 2, and the result was this. So it's probably cubic, right? So constant, linear, quadratic, cubic. So 2x cubed plus 11x squared plus 18x plus 9. Okay. All right. Now, if this was factorable, if I could, it might be factorable. Take a GCF out of this group. No, it doesn't look like it will be. So it's not factorable. What can I do? You're going to have to use repeated division. Here you have the option to. Here you need to. All right. So what I'm going to do with this is keep going. Continue to divide. So I'm going to use this other factor. Can't use this one. We already did that one. So that one's out now. Throw -3 in as the k value. All right. And then here's the coefficients. Don't go back to these coefficients. We're trying to break this function down. So 2, 11, 18, and 9. Add, multiply. Okay, so now I can break down this x cubed function as x plus 3 times this. So it's going to look like this now. 0 equals x minus 2 is still there, of course. This will be expressed as x plus 3 times this. 2x squared plus 5x plus 3. Okay, now hopefully this is factorable so we can finish this thing. There are factors of 6 that add up to 5, right? It's 3 and 2. I'm having a hard time fitting in here. I'm just going to break down this work right here. So let's see, 5x can be written as, so we're doing this. Right? Break this up. I told you these problems are intense and a little bit long, but you have all the skills to do it if you got the discipline to do it. Sit down and do it. So I'm going to write that as 2x plus 3x. Factor out the GCFs. Here I can take out a 3. And this is factorable. X plus 1 comes out. So I get x plus 1 and 2x plus 3. Okay, so now I have 2 linear factors I can replace for this. So here's the complete factorization as far as we could go, right? This is x plus 1 and 2x plus 3. So my zeros are positive 2, negative 3, negative 1, and negative 3/2. Okay? I know these take a while. I'm not loading you up with tons of them, but you know, this is a 2-day block, so I'm keeping that in mind too. I'm giving you kind of a hefty 1-day load. So you have a couple like these and a couple like these. Let me pause for a minute and take a look at some of the directions. I think there's something I want to talk about. Okay, here's the directions. Once again, like in our notes, you use your remainder theorem and synthetic division. That's enough. So I should see both of those steps in your OTI, okay? And they just ask you to do it for different K values. So you're going to do 53. Okay, check it in the back. You don't have to verify using another method. Like we skipped that step before too. Okay, this is going to be like example 12 and 13 right here. Just follow the same steps as we did for 12 and 13. And this one's like 14 and 15, where they give you a couple of factors. So verify the given factors. So to verify them, you check to see your remainder of 0. It's basically the synthetic division. This is step 1. Find the remaining factors, right? Break it down either way you want. Factor to use repeated division, and then use results to write the factorization and get all the zeros, just like 14 and 15, okay? So don't let these directions confuse you. E will be optional. You could, if you have those resources, go ahead and confirm your results, but E is not necessary. You do not have to put a graph down on paper, okay? So basically A through D will be required. Okay, we'll be starting 2.5 next lesson, and then our next quiz will be 2.2, 2.3, and 2.5. Take care.